one last shot at a possibly ambiguous case for a triangle. So we still have the idea that the base side is 3 centimeters and we have a 30-degree angle, which means our point C is somewhere along that line, but we're not sure exactly where. This time, the third side, AC, is only 1 centimeter long. So where is it? Is it going to be way up there, down here, down here, down here? We'll know in a bit. So I'll put C up there just to get us started. This says sine C over the side opposite from it is 3 equals sine B, as in sine 30 degrees, divided by, and side B, or sorry, the side across from B is AC, which they tell us is just 1 centimeter. So you get sine C equals 3 times sine 30 divided by 1, which is 1.5. So now we're supposed to solve this. You take the sine to the other side, and you get C equals arcsine 1.5, which is, grab your calculator, do second sine 1.5, and see what happens. And what should happen is your calculator should yell at you, because it turns out this is undefined. Sine can never be 1.5. It's always somewhere between -1 and 1. So this is impossible. How is it impossible? Well, take a look at this triangle up here. If this is 3 centimeters, then 1 centimeter is like that. And if you have a side that long, no matter what angle you put it at, you can't make a triangle simply because this red side isn't long enough to reach. It isn't enough length to close off the triangle, and the sine law knows that, and it comes back with this unsolvable thing to tell you that, hey, you're giving me measurements that can't possibly work. So the solution to this problem is the triangle cannot exist. A triangle with the measurements given cannot exist. So, as we've seen in our other examples, depending what angle comes out of here, you can get 2 answers that both work. You can get only 1 answer which works, or in this case, you can get there aren't any answers, or there aren't any measurements which work. All 3 of those can come out of the sine law.